In science, we have both quantitative data and qualitative data. Quantitative data is going to be data that provides numbers. It tells you how much of a thing changes with your test. So let's say you're testing a new cancer drug and you're testing it against placebo, and you find that there's a 50% reduction in your model in the lab that you're testing this new drug in. That's great. That's a great finding. Qualitative data provides context. Qualitative says, okay, this result that we're seeing, does it matter for every group or is it for a specific group? What are the reasons why we see a certain outcome within a certain group? So let's say, um, for instance, we see a higher result in a specific type of cancer in younger populations that live in a rural part of the country. Qualitative data is going to give us that context that there's maybe some type of correlation or causation between this disease and this context. A lot of the time in science, the issue is that quantitative data is published in its own group and qualitative data it's published in another group. They're completely siloed, completely separate. But if you find an amazing result, yeah, you've learned something, but out of context, does it even matter? And if you have context, but it never gets applied to a new experimental design, then how do we move forward in innovation? Really, a result with no context is virtually meaningless. So, not only do we want to test a new therapy or a new innovation, we want to, as scientists, as learners, understand, does this exist for everyone? And if it doesn't, why not? And how do we then probe our experiments to more meaningfully reflect what patients receive? So we need both quantitative data and qualitative data in the same bucket. We need everybody in the same room so that we can answer questions with context.